we're going to look more into streaming methods, which is how we handle real-time communication in Serverpod. And we wanted to make this interface as easy as possible because it's a pretty big topic. I don't know how many of you have built an app with some sort of real-time communication, like a chat or something like this. I built a bunch of servers before I built Serverpods and looked at all the different ways of doing it. And I think what we came up with here is so much easier than any other solution out there. Basically, the normal endpoint methods return a future, right? Instead, we can just return a stream, because that's how we typically handle a number of returns from a single methods in Dart. Dart has a great interface for handling streams. So that allows us to yield multiple values over time, instead of just returning a single value. And in Serverpod, you can yield any type of serializable objects, that's the data models, or the sets or lists of objects, or any of the sort of primitives. Thank you, everyone. I think it's quite interesting that I got to talk right after this one, because what if there was a much, much easier way to do all that we just heard about? So that's what I'm going to talk about today, and we're going to look at it through a sort of practical example. So I'm going to start by giving you a quick overview of Serverpod and how you do real-time communication with Serverpod. And then we're going to build a multiplayer drawing game that is similar to our place. I don't know if you've seen that on Reddit. You can place pixels, and everyone can place pixels at the same time at the canvas and build an image together. So let's dive in. I'm Victor. I used to work at the Flutter team when I lived in Silicon Valley. Now I've moved back to Stockholm and I started Serverpod. I'm also the main organizer of the Full Stack Flutter conference, which is an online conference. And I am also the organizer of the Flutter Stockholm meetup. So yeah, that's a little bit about my background. Before I get started, I want to ask a quick question. How many here have heard about Serverpod before today? So that's about half of you. How many have tried it out? Yeah, a few. Cool. So I hope this talk will sort of encourage you to take that step, because it will save you tons of time. So what is Serverpod? Serverpod is a backend framework written in Dart for the Flutter community. It's all open source. And we made something that is actually pretty cool. We made it possible to just add your methods in your server. We'll analyze your server code, and then we will generate the client APIs and include them in your Flutter app. So when you call the server, it's just like calling a local method in your app. So basically, working with DO or any of that, you don't have to even worry about that. We took care of all that for you. In addition, Serverpod comes with great logging. I'm going to show you just a screenshot of our log viewer. It comes with caching. Caching, when you build a server, is a super important part to keep the performance up, because when you talk with your database, that's like the most expensive thing you can do in your server. And it's often an afterthought, so it's really nice to have that built in from the start, a solution that just works. We also built an ORM, that's an object relation mapping to the database in Serverpod, and it's Dart first. It comes with database relations, joins, everything is type safe. We even do database migrations. It's like a complete solution written in Dart. There's nothing else like it outside of Serverpod today. Plus, we have everything else you would expect from a modern framework. Great APIs for uploading and downloading files, handling authentication, that's like signing in with email, social signings, Google, Apple, stuff like that. Streaming data, that's what we're going to look at today. That's our interface for doing real-time communication. You can schedule tasks. So say you have a user that signs up to your app, and you want to remind them with sending them an email 1 week from now. Then you can make a future call They will be serialized to the database, and Serverpod will, even if you restart the servers and everything, will figure out when to send that email, and it just works like magic. You can perform health checks on all your services, Serverpod itself, the database, but any other services that you connect, and monitor those. We made it very easy to deploy Serverpod. We have Terraform scripts for Google Cloud and AWS, but you can host Serverpod anywhere. You can run Dart, and we are also building a Serverpod cloud service that is currently in a beta version, but will be released later this year for everyone. But we're bringing new people on every week. So I'm going to show that a little bit too. So when you look at server logs in general, it can be quite hard to pinpoint things because all the messages just get sort of jumbled, and you have maybe thousands of concurrent users, so it can be hard to find them. Therefore, we made a log viewer where we group all the logs by the session, and we can also store stack traces together with your database queries and exceptions. So it's very easy to pinpoint if something goes wrong in your server. And we call that Serverpod Insights. Next, we're going to dive into sort of a quick basic tour of Serverpod, so we can sort of get into the real-time communication part, and then build a game, of course. First, a quick overview. You have configuration files for production, development, staging environments, and here you define, which ports your server will run on. Next, you have a passwords file where you can add any passwords you need your server to access. And in the endpoints directory, you place your endpoints. Here's just an example endpoint with an example method. We're going to look a little bit more on how you do that too. And finally, there's a model directory. And here you place your data models. And data models are built into Dart classes that you can transmit back and forth to Serverpod from your app, but also persist in the database. So when you start the Serverpod project, it looks like there's a lot of files and places, but these are really the only parts that you need to pay attention to. Every time you change your models or your endpoints, you need to run serverpod generate, and then all the files gets updated. So let's look at creating endpoints. You typically place them in the endpoints directory. Technically, you can place them anywhere in Serverpod now, and the Serverpod generator will find them. But they will need to extend the endpoint class. That's the only requirement. And then you add methods to your endpoint, and they need to return a typed future. And the first parameter needs to be a session object. And the session object in Serverpod is a little bit special. It contains information about the call being made to Serverpod, like you can get access to all the HTTP headers and that if you really want to. But it also gives you access to the database and to other features like the future calls or pub sub and stuff like that. And you can pass both sort of Dart primitives like integers, strings, URIs, but you can also pass lists of these types and any serializable objects or models both to and from your endpoints. So this is an example. This is as easy as it gets, right? We have a class that we call example endpoint. It extends the endpoint. We add a single method that we call hello. It returns a future string, and it takes the first parameter is the session object, and then we have the name, which is also a string. And then we just return hello and whatever string we pass in. And then we run serverpod generate, and to call this method from our app, we just do we need a client. It's one line to create a client, and then we have the example endpoint and the hello method, and we'll get the future back, so we need to use the await, and then the result will be hello world. So instead of doing everything we heard about in the past talk, you can do this. Just saying. Next, let's look at the data models that we can build. In Serverpod, you define them in YAML, and we picked that for a couple of reasons. It makes it possible for us to sort of tack on more information that you would in a Dart class, and it also makes it possible for us to generate these models for more languages than just Dart in the future. Just place the models in the models directory and run Serverpod generate to make them accessible both in your server, and it will also generate the classes in your app. So this is an example of what a model looks like. We make a class called company, and it has 3 fields: name, which is a string, the founded date of the company, and you can use Dart types like strings, date type, date, time, URI. Basically, we cover most of the basic Dart types here. And obviously, you can also use other models. You can use lists, sets, maps, even Dart records work. And then you just use them. After you run Serverpod generate, you can use them just as any Dart class. And all the fields you access like properties. Very straightforward. And a pretty cool feature of this is that you can also map them to the database by adding the table field to your database model. And then we generate all the bindings to the database, so you can work with that in just with Dart objects. But I'm not going to cover that too much today, so that's maybe a topic to look into if you're building a real server with Serverpod. That will be sort of a key component as well. We're going to look more into streaming methods, which is the how we handle real-time communication in Serverpod. And we wanted to make this interface as easy as possible, because it's a pretty big topic. I don't know how many of you have built an app with some sort of real-time communication, like a chat or something like this. We have a few. I built a bunch of servers before I built Serverpods, and looked at all the different ways of doing it. And I think what we came up with here is so much easier than any other solution out there. Basically, the normal endpoint methods we looked at before return a future, right? Instead, we can just return a stream, because that's how we typically handle a number of returns from a single methods in Dart. And Dart has a great interface for handling streams. So that allows us to yield multiple values over time instead of just returning a single value. And in Serverpod, you can yield any type of serializable objects, such as the data models or the even sets or lists of objects, or any of the sort of primitives. Something I didn't mention before, but in Serverpod you can even serialize exceptions. So you can, in one of your endpoint methods, you can throw an exception. Serverpod will serialize that, send it over to your app, unpack it, and then rethrow it there. So that's a great way of handling errors, and this works in streams too, which is super cool. So this is we're back to the sort of very simple example here with just returning a future int to get a value. How do this look like if we're making it a stream instead? So we rename it into a countdown method. And instead of just returning a future int here, we return a stream of ints. And we need to use the async star to do that. That will tell Dart to return a stream instead of a future. So we just do a countdown from 10 to 0 and yield each value and wait 1 second between each of these values being returned. And if we want to call this method from our app, this is what that will look like. Typically, we can get the stream by accessing the client. In this example, it's the example endpoint, and then the method, which is the countdown method. And then the easiest way to read multiple values from a stream is to use the wait for. So here we just get the values one by one and printing them out to the stream. And that's it. That's all you need to do like real-time communication with Serverpod. Under the hood, let's see if I have a slide about that. No, I have one other slide here before. And this is an example of if you want to pass streams to Serverpod. You can do that too. You just do it as a parameter. And you can even pass multiple streams to a single method. In this example, we just pass in a stream and return the every time we're passing the value to that stream, we'll return the stream that sort of doubles that value. So that's the simplest example I could think of. Right, so how does this actually work under the hood before I move into the next section here? When you do real-time communication, there are basically two methods you can do it. The other one is to use socket communication to the server, but that is a problem with that, and that is that it doesn't work with Flutter web, and there are also firewalls that will block it. So the second option is to use WebSockets, which basically opens up HTTP connection that is sort of persists, that can send multiple values back. So that's what we use. And if you've ever worked with these raw connections, it's pretty hard to keep track of the life cycle of that. And that's something we handle all for you with Serverpod. So even though you maybe connect to maybe more than one streaming method, they all pipe through the same WebSocket. So you just use one connection to the server. It's using routing inside the server to get you to the right method, but it all happens under the hood. And also on the clients, it's very easy to sort of handle any errors that may happen. All right, one other feature that you probably want to need if you use streaming methods in Serverpod is what we call message central. And that's how messages are passed around inside the server. So this is commonly known as pub/sub because you can publish messages in one part of the server and listen to those messages somewhere else in the server, or even between servers. So in Serverpod, you just post messages to a named channel, and you can listen to these named channels somewhere else in the server. And you access the message central through the session object, which is that first parameter you pass that you have in your server methods. And what's really cool, this also works across a cluster of servers. So if you have a big application with many, many users and need multiple servers to scale it up, these messages can be passed between the servers and use the exact same API for doing that. So it's really seamless. So this is an example of a simple chat server. Basically, here we have a method that posts a message, and we have two parameters. We pass a message to the server, which is one of our data models, and then there's a recipient that's like an ID of the user that should receive this message. We just access the message central through session.messages, and it has a method called postMessage. We create a string that is the name of that channel that is unique to that user, and then we post a message. And then somewhere we add another method to listen for message for specific users. So here we pass back a stream of messages. And the first thing we do here is to find out what is the user ID of the current user. And then we create a stream by calling session.messages create stream with that name of that channel for that user. And that will get us all the stream of those messages that we post into that channel from some other place in the server. And then we just yield them back to the user to pass them. So this is actually all you need to do to build a chat server in Serverpod. I mean, in a real case, you probably want to handle a whole lot more, maybe security and validate users and stuff like that, and pass attachments and whatnot. But this is the sort of core part of that and code that actually works. All right, let's move on to the fun part of the presentation, building Pixorama, a multi-user drawing game. So we have this pixel surface where we want people to be able to place pixels, and everyone should get these updated pixels. So there are basically two parts. Okay, so let's see. First, we need to create the Serverpod project. And Serverpod comes in two sort of formats. One is the regular Serverpod with like the database bindings and all the bells and whistles. There's also a mini version of Serverpod that is called Serverpod Mini that can come without the database. So that's what we're going to use for this project. So that simplifies things a little bit, although it's not that hard to connect it to the database if you need that. So to run your Serverpod Mini, the only thing you need is basically to use Dart and nothing else. It will work. We're going to create two models for this. When it's going to work this way. So when the user connects, they will get the full image sent to them, and then they will just get the updates that everyone else makes to the image. So first we have an image data. This is the full image. And we have the pixels. It's a byte data. In Serverpod, you can pass binary data, both to the methods and from the methods. So that's basically a list of bytes that describe the image, where each byte is a color of the pixel. And then we just set the size, which is like the width and height of it. And next, we have a model for these image updates. Whenever someone taps on the screen or clicks a pixel, we want to distribute that to everyone. And we do that with an image update. And this has just two fields. It's a pixel index. That's the index of that very pixel. And then the color index, which is the index of the new color. And we're going to use a palette of just 16 colors for this. Whenever we add the models, we need to run Serverpod generate to get those models available to our code. And then we can start looking at building the endpoint for Pixorama. And this is where like all the server-side magic will happen. So we call it a Pixorama endpoint. We define some constants here. We have the width and height of the image, 64 by 64 pixels, which makes the number of pixels 64 by 64. We use a palette with 16 colors, and we set the default pixel color. And then we create pixel data. So that's basically the image, but just as an array of bytes. And we use a uint8 list for that. That's basically just a list of bytes, which you can access as integers. And we will fill it with the default color. So that's sort of the setup for the image. And then we'll need a channel to pass things. Remember the message central, we need a name channel to pass all the messages around in the server. And we call that just pixel added. And then we add a set pixel method. So this is a method that we'll be able to call from our app. And it will just take a color index and a pixel index. So that's when someone taps a pixel, we'll call this method and set that pixel. And we do that by just updating our pixel data, which is an array of all the pixels in the image for the pixel index and then the color, new color. But we also need to notify everyone that's sort of viewing this image that something happened. So we also use the message central, which we access through the session object, session.messages post message. And we create an image update. That's the model that we created earlier with a pixel index and a color index. So now we have a way to sort of edit the image for all our users, but we also need a way to be able to update them so they can see all the updates. And we use a streaming method for that, that we call image updates. And with streams are a little bit different from other Serverpod methods. All other methods that return a future needs to be typed, but streams, you can pass different types of objects through the stream. So it's basically, it can be dynamic. You can also type it if you want. And that's very useful when you work with streams, as we'll see here shortly. So first, we create a stream from the message central. This will allow us to listen to all those, every time we set a pixel with the set pixel method, a message will be sent to message central, and we want to listen to these messages here. So we create a stream through the message central to get those updates. And then we're going to yield two values. The first one is the image data, which is basically the current image. We have the pixel data, and then the width and the height. And next, we want to listen to the stream that it gets all the updates and pass them on back to our app. So when the app connects to the server, it will first get the full image, and then we'll get all the updates to the image after that. So that's actually all the server code we need to get this game running. Let's have a look at how this looks like in the app itself. We're just going to look at the real-time communication part of this. We're using a package called Pixels to do this. And that has the ability to draw a pixel image and edit it. And that has a class called Pixel Image Controller, which contains the image itself, and you just pass that to the pixel image, and it will display that as a widget. And we have a Pixorama widget, and this right now we're just looking at the state for the Pixorama widget. So when we first start or add this widget, the init state method gets called, and here we'll start listening for updates. So let's look at this listen to updates method. So that's just a future, so it will start running sort of behind the scenes when you call it. And here we do something that you typically, I guess, is bad programming practice, but in this case it's quite convenient, and that's making a while true loop. But for this app, it's actually the right thing, because we always want to sort of connect to the server. There's nothing else to this app. So while true, we will try to connect to the server. If anything goes wrong, we'll get a method stream exception. That is like if the connection to the server gets broken for one reason or another, we'll get there. And if that happens, we will delete our image controller, which has all the pixels. If it's null, we'll just show the sort of spinning widget that is loading. And then we'll wait for 5 seconds and try to reconnect again. And it can be smart in these scenarios to add a little delay before you try to reconnect. Because imagine if you make your server go down, and then you have maybe tens of thousands of users trying to connect to your server. And they try like thousands of times per second. That would probably make it pretty hard to sort of make your service available again. So good practice, have a little delay before you try. That mustn't necessarily be 5 seconds, but just as an example. Okay, let's look at the inner part of this try block, because that's where like the sort of magic will happen. So we get our image updates, which is this stream of updates. The first message there will be the image data, we know, and then we will get the image updates. So we can make an await for to read these messages one at a time. And if we get the image data, we will just set state and update, create an image controller. So before we have the image controller and it's null, we'll just show that spinner. And when we get the data, we have an actual image to show. So we create a pixel image controller with data that we get from the server, which is like the pixels. We add a palette and the width and height of the image. And next, when we get an image update, someone click the pixel somewhere on the screen. We just use the set pixel index method of the image controller to update that single pixel. There's one more part to this that I forgot to add to the slide, but you will have to imagine it in your heads. And that's when we click a pixel, we also call that set pixel method. And that's just like client.pixorama set pixel. It's pretty easy. And with that, we should have a complete server, but we need somewhere to host it to. And we're making a really cool solution at Serverpod called Serverpod Cloud. It's currently in a private beta, so we're slowly bringing on more and more clients on it. But to take your Serverpod and host it in Serverpod Cloud, the only thing you need to do is create a new project. S-Cloud project create Pixorama here. And then you do S-Cloud deploy, and we take care of everything else, set up your whole infrastructure with load balancers, a database if you need that, pub sub, file uploads, the whole shebang. You can use custom domains, sets up your certificates. If you want to host it yourself, you can do that too. We have great tutorials for setting it up on Google Cloud. You can use it either on Cloud Run, or is it called Compute Engine? You can also, we also have Terraform scripts for AWS. So you have many options for hosting Serverpod. You can just do it on your server in your garage with just Dart run, and you're good to go too. But if you find us on social media, there's a waiting list if you want to try it out early before it's released to everyone. With that, we can actually try the game. It should be available at pixorama.live if you want to play around and try it out. I haven't tried it with this many users, so fingers crossed everything will work. Serverpod Cloud is still in beta, just tagging that on there. Where to go next to learn more about using Serverpod? You can find us at Serverpod Dev. The whole Pixorama project is available on GitHub, serverpod/Pixorama. The server is literally a page of code, and the app is almost the same size, so it's very easy to get started with. You can find us on Blue Sky or X or LinkedIn. With that, I'm open for any questions you may have.
Give a round of applause to Victor. Thank you very much. That was a great one. And of course, thanks for being here as you are actually. There are a few questions in here and online. So currently I have access to online questions. Yes, they will be answered from now on.